Hi, we're going to start with our second section of chapter 4. This is going to be 4.6 that we're starting with today. So first thing we're going to look at is talk about molecular shape. And so we've been working on Lewis structures, but the Lewis structures only really tell us what's the connection between the different atoms, like how they're connected, but it doesn't really tell us about the geometry or the shape of the molecule. And so to determine the shape around the atom, we first look at how many groups surround that center atom. The center atom is going to be our focus for a shape. And the group we're talking about electron groups can either be an atom or a lone pair of electrons. We use what's called the valence shell electron pair repulsion theory to determine the shape. This essentially means that the electrons on the outside of the atom, the valence shell electrons, they repel each other. So they want to be as far apart as possible. And so when we look at the number of groups around an atom, we want to position them so that they are as far apart as they can be from each other, the electron groups, and think about it also in three-dimensional space. So there are three main shapes that we're going to talk about: linear, trigonal, planar, and tetrahedral. There are other shapes kind of under trigonal planar umbrella, and there are other shapes under the tetrahedral umbrella that we're going to talk about, but there's going to be three main bond angles and that we'll discuss. So the linear shape is designated by a 180 bond angle. So if you have two electron groups around the center atom, then the farthest apart they can get from each other is 180. And that's going to make a linear shape. If you have a center atom like this red one, and you have three electron groups around the center atom, let's say that these are three bonds here in this shape, the farthest away they can get from each other is 120 degrees. So that's going to be trigonal planar. And we say planar because this is flat on the planes. This would be like flat in the paper. Linear is also flat, so we could lay it out flat on the paper. And then tetrahedral is a little bit more complicated. Basically, the atoms are not flat. This is kind of a three-dimensional shape. And so what we use to differentiate this three-dimensional shape is this little wedge. So this guy is a wedge, and it means that the atom or the group is coming out of the page. So we think about it as coming straight out of the page towards us. Then we also have the dash. And this is the atom or the group is going into the page. So back into the page. These two, the wedge and the dash, really help you get a three-dimensional feel. So I want you to think about tetrahedral as like a pyramid. So if I kind of draw like a three-dimensional pyramid here with a little flag on the top. So you can get a sense that this is a three-dimensional shape just the way that I've kind of drawn it here. But if you can kind of think about a pyramid with a flag on the top, that's kind of what your tetrahedron looks like. So it's got this pyramid base and then this little extra atom or something hanging out on top. So my atoms are kind of like this. And there's one in the center here. And then we have this pyramid shape. I know I'm not the drawing isn't perfect, but you can I will talk about I'll bring a model to class and so we can kind of look at it together. If you want to come into office hours, I also have models to play around with. There's a website also, the simulation, that has different models that we'll look at, but yeah, so the first two are kind of flat. They can be flattened on the paper. The last one cannot be flattened. If you take four things and you put it around an atom, oftentimes we'll think about the four things as maybe having a 90-degree angle. But we can actually get more distance between those electron groups by popping it out into three-dimensional space, and it gives us an angle of 109.5. So these three angles are the only three angles that you need to worry about memorizing. Two groups is at 180, three groups is 120, and four groups is 109.5. This is what you're memorizing for this section. So you're going to memorize these common shapes around the atoms. When we're talking about number of groups, this is total number of groups on the left side over here around the center specifically. bonded to center. So all of this is based on that center atom is kind of the star of the show, number of lone pairs around the center. So if we have two groups around the center and both of those groups are atoms and no lone pairs, we're going to have a linear shape. The bond angle is going to be 180. And then we have some examples. I honestly think just memorizing like the examples is helpful because then you can say, well, if it looks like CO2, if it looks like HCN, even if it's not exactly those, if your Lewis structure looks like these Lewis structures, then you know that it's going to be linear 180. Then we have our trigonal planar. This is three groups around the center, three atoms, no lone pairs in the center. It's going to be called trigonal planar, and it'll be 180, or sorry, 120, and you can have a couple of examples here. There's one more I'm going to throw in here in a second, which is a bent shape. So we're going to just add this one. So if you have three groups around the center, but there's only two atoms and one lone pair, what we get is a shape that looks like this. And it's also it's just around 120, so it's like approximately 120. And then one good example of this would be SO2. We've talked about SO2 before, but that would be an example of that shape. And we're going to call this bent. So there's two different bents. There's a bent that's 120 and a bent that's 109.5. The reason why it's a little bit less than or around 120 is because when you have lone pairs, they kind of push down, they take up more space, they push down on those bonds. Again, in class, I'm going to show you some models and we'll do a little bit of fun activity to think about these different shapes. Then if you have four things around the center, all of them are atoms, and zero lone pairs, we got our tetrahedron, right? This is a three-dimensional, like a pyramid with a flag on the top. It's 109.5. Your classic example is CH4. Now, if we start to take away the atoms and just put lone pairs, then we're going to get a little bit of a different shape here. So if we have four things around the center, but three of them are atoms and one of them is a lone pair, we call this trigonal because it's like a triangle because it's got three things attached to it, but we call it pyramidal. This is like our pyramid, but without the flag on the top. It's about 109.5. It's a little bit less, and your classic example is NH3. Then we have four things around the center, but then we have a fraction of 2 and 2. So two bonds, two lone pairs. This is bent. Again, those lone pairs kind of push things down. This one is back in the plane of the paper. So if it doesn't have a wedge or a dash, it's not popped out in 3 dimensions. It's just kind of flat in the paper. This one is also a little bit less than 109.5 because those lone pairs are kind of pushing down on those bonds, making them a little bit smaller. Classic example for this is H2O. So going into these a little bit more. So this is linear. This is CO2's Lewis structure. So how do I determine how many groups are around the center? We're going to literally just look at the groups around the center. So if you look at the CO2 Lewis structure, you have two areas of electrons around the center. There's one double bond on the left side and one double bond on the right side. A double bond counts as one group. Those just happen to be bonds. There's no lone pair. So in my chart, I'm right here. Two things around the center. They're both bonds. There's zero lone pairs. So now this is my shape. Linear and 180. Now, if I have trigonal planar, let's count around the center atom. I've got 1, 2, 3 things around the center atom. All of them in this case are bonds, no lone pairs. So I'll go here. 3 things are in the center atom. All three things are bonded, zero lone pairs, trigonal planar, 120. I'm going to add in my other example that for some reason the textbook is taking out. So if I had, for example, SO2, we've talked about SO2 before in class. It's a double bond on one side and a single bond on the other. For what we're learning in this class, this is acceptable for SO2. So how many electron groups do we have around the center? We have 1, 2, 3. So again, a double bond counts as one group, a single bond counts as one group, a lone pair counts as one group, and a triple bond counts as one group. So there's three groups. So let's think about these now as that we need to show a 120 because right now it looks like it's 180 and 90 degrees. So if we redraw this to kind of really show its shape, we can give you more of that 120 feel. So you may be asked to draw things in correct shapes on your homework or in like a lab class. But again, we still have our three electron groups around the center. So one of them is a lone pair. So we go into the chart and just add this into your chart. Three groups, two bonds, one lone pair is going to look like this. It's going to be bent, and it's based on the trigonal planar because it's still three things total. So it's around 120. It's a little bit less though, because those lone pairs, they wind up kind of pushing down on the bond. So they make this a little bit less than 120. So we can write that here. I can say this is bond angle here is a little less or about 120 degrees, a little less. You don't have to know exactly what it is. I'm not asking you to memorize each individual bond angle. If we have four things around the center and zero lone pairs around the center, we have 1, 2, 3, 4 things around the center. None of them are lone pairs. We're talking about the tetrahedral, and the angle is 109.5. If we then take our four things around the center, and then, but one of them is a lone pair, we get this pyramid shape. Remember, the tetrahedron is a pyramid shape. It has a little flag on the top. This doesn't have that flag on the top, so we call it trigonal pyramidal. So we can kind of see how that would look. And here it shows you 107, but again, you do not have to memorize that. You would just memorize 109.5, but know that trigonal pyramidal is a little bit less because those lone pairs, they push down on the bonds. And then if we take away two of the bonds and we have two lone pairs and two bonds, we still have four things around the middle. So we kind of are setting up in that pyramid, but two of the points of the pyramid don't have anything on them. So we're just looking at this and it's just bent. And you can see it's 105 for real for water, but you're only going to memorize 109.5. And just know that it's a little bit less than 109.5 is enough. Okay, that's all for this video. We'll see you in the next one.